All right, I'm going to go ahead and get started. Good to see everyone back. Uh, after a little time off. We're at week 13. We're winding down to the end mostly. Um, as I said before, we're going to cover sections 13 and 14, but it won't be too bad. All right, so for our schedule today, 13, we're going to go to DDL, which is, we began talking about that last time, but this is basically data definition language, creating tables, using data types, modifying a table. Um, and we have our practice, and then basically just a section 13 assignment. And then we're going to go right into section 14, and that's constraints, intro to constraints, primary key, foreign key, and check constraints basically used to keep the validity of the data, and then managing constraints. And our practice, and the section 14 assignment, which is pretty short, and the 13-14 quiz. All right, so that's our plan for this evening. Um, it seems like a lot, but it's not that bad, so you all will be okay. So I'm going to switch computers, so bear with me. Let me finish taking attendance and go over to my other system. All right. All right, can y'all hear me okay still? Good. Okay. So let's get right into it. Let me get the module started. So section 13. So let me share my screen here. SQL developer. And just a reminder, I didn't show it on the slides there, but these assignments will be due this week, the end of the week. So all right. Can y'all see my Canvas screen? Yes. All right, into section 13. Okay. Once again, this section is all about the data definition language, or basically tables. You're getting into the crux of some of the database management. So creating tables, 13.1, list and categorize. Our objectives: list and categorize the main database objects. Review the table structure, which you already know how to do, which your describe command. Describe how schema objects are used by the Oracle database. Oh, hold on, someone's coming in. All right. I need to make a note. Someone just came in. Yeah, who just joined us?
Oh, this is Whitfield?
Okay, thank you.
No problem.
All right. All right, continuing the objectives. Create a table using the appropriate data type for each column. Explain the use of external tables, which we're not going to get into that, but you will definitely see that in industry. External tables are pretty common outside of a database, a particular primary schema, and then query the data dictionary. And this is basically the dictionary that tells you all about your tables and what's associated with what, et cetera. So let's get into that. Oh, wait, another person coming in. So, all right. Okay, let me take a second and record these particular individuals before we get into our lecture material. I'm going to stop sharing for a second here. Go back into the attendance. And just bear with me. I'm pretty sure these individuals want to be counted present, so. All right. Rylan. Okay. Let's get back into it. All right, here we are again. In our lecture material. All right. Creating tables, a fun thing. So up until now, we selected update, insert, and delete. Now, wait, we haven't gone through this particular section, have we? For some reason I'm feeling a little bit of deja vu. Please tell me if this is a repeat. If not, we need to be reminded. As a DBA, you'll be expected to know how to create tables along with updating data. So in this lesson, we're going to look at what we call DDL, data definition, and you're going to learn how to create tables. And that sounds exciting. So these tables will be small compared to a regular database. And truly, there are tables out there with millions of rows. I've dealt with them. I've dealt with these size tables for a while. Like I said, you will also learn about external tables, which are similar in structure. Basically, they're very similar, and usually they fit in with your schema. And the queries are just about the same. No big deal there. So an Oracle database can contain many different types of objects. Your primary object is generally your table. So this I'm going to introduce you to the most commonly used objects. And basically, this is where the data dictionary will come into play. You'll get to see essentially how the database is structured from a table perspective. All right, so just to give you a list of objects, primarily the table is normally your primary object. So usually are associated with that, but there's index, there's constraints, there's views, which are just like tables. There's sequences and synonyms. And you'll see that these are all basically tied into, for the most part, the primary object, which is a table. So some of these objects can exist independently, and others cannot. They really depend upon, your particular object or the table. So some of the objects take up space, known as storage, typically in a system. Database objects taking up significant storage space are known as segments. So you will have to remember that. And segments are still pretty much associated that way. All right. One more attendee. All right. Tables and indexes are examples of segments. As a value stored in the columns of each row take up significant, basically they do take up a lot of space. I do remember the day where we had to pretty much manage and monitor the amount of tables in a DBMS. Now, I mean, with giga and terabytes of data, and it's usually not a big deal as far as space. But when this lesson was written 10 years ago, yes, there's still some consideration as far as space. So views, constraints, sequences, and synonyms are also objects. But the only space they require in the database is in the definition of the object. So that just means that they don't really take up a lot of space. Views are usually used at a particular runtime, and they're depending upon your database structure, they're usually temporary. Constraint sequence and synonyms are all a part of an association with the table. So just remember that. All right, the database stores the definitions of all database objects in the data dictionary, and that's essentially where you can view all of the objects, and we will be querying the data dictionary. So have you ever wondered, Oracle knows which column? Yeah, this is all defined in the data dictionary. So if you specify select star from jobs instead of select job ID, so how does, I mean, it's almost intuitive that essentially, and wildcards have been around forever. So yes, this is a rudimentary lesson that says, yeah, database objects are configured a certain way that your queries will be recognized. And we're moving into an era where, yeah, I don't know if queries, oops, one more. All right, everyone's present. Queries are going to be obsolete. Well, I don't think so, in my professional opinion, since these types of databases make up most of the storage as far as data, around the world. So, if you're thinking that the whole idea of SQL and querying database is probably going to be passé with the large data models and things like AI and LLMs, possibly in a number of years, but I'm pretty sure that they will not. So my point is that, or the point of this lesson is that the data dictionary, the way it is in these RDBMSs, are pretty important because it defines all of the objects and how they associate with each other. And you just essentially need to know that the data dictionary holds everything that you need to know as a database administrator or user about the structure of your data. So here we're given an example of how the data dictionary is queried and how it reads your particular SQL queries. We don't really use Application Express anymore, which is an abbreviated version of the developer. So essentially, we don't have to worry about these scenarios too much, but it's always good to address these so that essentially, one, how the data dictionary works, and then what happens when you actually run a query in the developer. So if you want to see, as it's illustrated here, if you want to open up the object, well, the object browser is a little bit different in SQL Developer. Let's see if I can illustrate it here. This is the one thing that, well, I will definitely investigate that. But this particular view is a little bit different, especially when you run a describe. The describe is abbreviated quite a bit in the current version. And basically all the information that you need to know about a table from even as a DBA, can be ascertained or can be obtained using the describe command. So DESC. Let me just run a quick example here. Well, this talked about the jobs table. As you know, if you run a describe and run that particular query, it will, wait, we don't have a jobs table. We have an employees table, right? So if you want to, All right. No, I didn't have this set up. All right, I'll get back to that. I need to make sure that's set up for viewing your output. All right, let me make sure. Okay. Here we go. All right, so if you run a describe command, basically your output will describe the attributes of that table, and of course have it several times. All the columns, if it's not null, and the data type, and that's usually what we're concerned about in our table structure. So just keep that in mind while we go through some of these aspects. So all data in a relational database is stored in tables. You probably figured that out. So when creating a new table, use the following rules for names and column names. Okay, column names must begin with a letter, must be 1 to 30 characters long, must contain uppercase, lowercase, 0 through 9, underscore, $, and or number sign or hashtag. Those are the only allowed characters for a table name. You must not duplicate the name, etc. And you must not use a reserved word like table or column. Basically, the system will not allow you to use those. That's what the reserved words are. Generally, and please get into the habit of this. I mean, particularly, well, I'm not going to ask you to be scripters or programmers, but it is useful to use descriptive names. Like if you have a table full of students, you want to call the table students, not people or children, although students are sometimes very childlike. And table names are case sensitive. So understand that all uppercase name is different than the name if that has different cases in it. Table names should be plural. I mean, that's common sense. You know, you want to name it students since it's a list of students. So creating tables is a part of the DDL, the data definition language. Also, there's other statements. Creating tables is to create, there's alter, drop, rename, and truncate. So to create a new table, you must have the create command or create table command, or you all have create table privileges, so you don't have to worry about that. If you're in a database system scenario and you're not the DBA, you obviously will not be allowed to create tables, and you have to request that privilege. And then privileges, we're going to talk about this later, are part of the DCL, and that's the control language. And basically that's another, you have the DML, DDL, and DCL. We did talk about that briefly. And obviously tables belonging to other users, and we don't have to worry about that in our schema. You are essentially the DBA of your instance. So you have all the privileges. So we are going to talk about granting privileges and all that and users, etc. as we continue. So here's the general syntax for creating a table. It's create table, use those two keywords, create table, and then the table name, and then your column name, data type, and then we're going to talk about the default expression. And we did talk about it. You can actually set a default value every time that table is created for that column. All right, that's what the default expression is. Okay. All right, here's some examples. Create table and my CD collection. CD number is the title of one column, and it's a number data type. Title, it's a varchar or string data type. Artist, varchar. And the numbers inside the parentheses are the size that you're allocating for that column. All right. And then we have a purchase date. It's a date data type, and the default value of that purchase date is the sys date. And if you remember, the sys date is just today's date. So when you create this table, it'll automatically set the date to that purchase date column to the sys date. Now, that's good to do because you can see the default structure or the form of the date. So if you want to write to that particular column, you know the basic value, the basic way that the value should be structured to be written to that column. And then here's another example: create table, my friends, my first name, last name, email, all varchar string, and then birth date. No default there, but we talked about date, data type. There's a specific, in your system or our system will recognize certain data types and use the default structure unless there's, these particular systems are a lot easier. And we'll talk about that as we go as well. All right, let's briefly mention external tables. Whenever you speak of an external table, it's not a part of your schema. Remember, your schema is your basic database that's defined for your department or your company. But in many instances, and all that I'm indicating here, you may have access to an external table. Maybe it's a cloud table or some type of network table, and you'll be able to query that table just like you would query your local tables. Now, this talks about flat files and all that. This generally, if you have access to the external table, it's something that just like you set up the SQL developer, you would set up a connection, another connection to the external table. Just like and essentially we have it easy because we're connecting essentially to a cloud instance. So you would just set up another connection. You would do the plus here, and that's the more updated method. You don't have to transfer it into a flat file, anything that's illustrated in the lecture here. I'm going to kind of buzz through these. You're going to read through these. This was the old directive, and it was very archaic, very slow, but it was pretty much the only way that you can connect or bring in the values, all of the data in an external table. It was almost like a complete import-export scenario. But now with the advent of the cloud, as you probably are aware, it's a little bit easier. So there's some examples in the lecture. And as I said, it's a little bit simpler than this, but you are going to run through a process of connecting to an external table in this method. So I breezed through that. You more than likely will never have to run anything like that outside of this class. I have not run into any type of data dictionary for at least 20 years that involve flat files and an export or an import. All right, moving from that, I want to talk about the data dictionary. There's two types of tables or kinds of tables that exist: user tables and data dictionary tables. You can use SQL statements to access both kinds, as you are probably aware. User tables are the ones that you have access to: employees, departments, jobs, etc. The data dictionary has basically, it contains all of the particular objects and information about the objects. So like user objects, user tables, user segments. So we are going to query those so you can see that they do exist. And this is the kind of the internal structure of how the data, the relational database system is defined. Yes, and they're owned by a special Oracle user called CIS, which is basically the system to make these tables safe from accidental user access. They are protected. You can query them, but you can't change. They're changed only by the system. So you can't do inserts, updates, or you can't do anything with these tables because you will compromise the integrity of the entire database, which essentially this is the framework of your data. So you never really shouldn't have a need to change any of that, just view. So just keep that in mind. The data dictionary is just a view. If you ever have the opportunity to be a database administrator at that level, meaning at the very beginning of building the schema, that's where you would deal with some parts of the data dictionary, but not all. Most of the parts are the Oracle system is smart enough now, we'll say that, quote unquote, that it will construct most of the aspects of the data dictionary for you. All right, so as far as querying the data dictionary, it is pretty simple. So you can, select table name, status from, basically here's a couple of sample queries that you can use. User tables, all tables. And basically you're getting an idea of how the tables and how the schema is structured. So we're going to do a couple of those, or you should do a couple of those based on the objects that you're looking for. So, for example, if you want to investigate indexes, yes, there's a user indexes table. And indexes are very important for relational database system. This is the item that helps to organize the data in those tables and sequences and so on. So it's just a simple query. Remember, just a select query for your data dictionary. All right, so there you go. Creating tables, a data dictionary, table, one of the primary objects. External tables, yes, I breezed through that. It's a different aspect now. If you ever run across an external table, I guarantee you it's not going to be anything about dealing with flat files. And then schema, remember schema. Someone needs to be muted. Okay. All right, we got rid of the echo. Who just joined us? All right, anyway, let's continue. And then default, remember, and you have to review some of the values. When you create a table or alter a table, you can add a default value to a specific column. All right. Okay, any questions about that whiz bang section? Creating tables. You'll have many chances to practice with that. So let's move on. All right, on to topic 2, using data types. So basically our objectives, create a table using timestamp, and timestamp with the time zone is very, very useful. Creating tables using interval year to month and interval data second. These are just specific types of data types that will help to, I guess, define the data, give examples of organizations and personal situations where it's important to know which time zone. And yes, we're in a global, basically a global operational society now. So, and even within our own country, I mean, there's different time zones, different situations. You may be meeting someone from the East Coast, et cetera, et cetera. So listen, provide an example of each of the number, date, and character data types. Yep. So here we go. All right. Using data types. So if you ever travel to another country, you quickly find out, money and time, things are a little bit different. So if you want to buy something, I mean, this is kind of a cliche, kind of a cliche example, because I think we're smarter adults to know that although all the traveling that I've done, I've never had anyone deny me giving them US dollars. Although I don't know whom, there's some value. But anyway, that's a side note. Different types of data have different types of characteristics, and the purpose of which is to efficiently store data. Yes, this is the whole idea. So basically this lesson will go over different data types. So each value manipulated by Oracle has a data type. A values data type associates with a fixed set of properties with the data, numbers, strings. These properties cause a database to treat values of one data type differently from values of another data type. I can tell you now from experience, if you use alphanumeric and you have numbers, your system will recognize that. And there's certain, we'll call them cheating systems that will help you, and it will not give you problems as far as the types of data. 10 years ago is a different story. Now it's not as bad as it used to be. So different data types offer several advantages. columns of single type produce consistent results. Yeah. And basically in our data type or database, you cannot, because of the constraints, and we'll talk about that later, you cannot insert a wrong type of data in a column that's expecting a specific data types. Especially date. Date is the tricky one. You know, you have to do some of the conversions just to make sure. 1 second here. Let me close my door. All right, I just had to close my door. Individuals wandering the hallway, even this late. All right, so data types are important. And for our purposes, learning at this level, you're primarily going to deal with strings and numbers and dates. And just make sure you know the difference between the two and how to create the conversions, etc. That's usually the tripping point, but just be aware of that. All right, let's continue. Okay, so as I just said, and the most commonly used column data types are characters and numbers. This is a char and varchar. These are character data types. The clob, that's an object, that's a large data type. And you probably won't use a clob. That's something very new. And it's actually larger now than 128 terabytes. So char and varchar, so these are commonly used based on the size. I would just say varchar 2 is essentially the default as far as strings. And you can use that for any size because it's variable size. Char is usually a fixed size, and it's usually something for specific purposes. That's the difference. And then numbers are just number. So yeah, I'm pretty sure you won't go beyond a number higher than 38 digits. In the old days, the big number, well, anyway, it's something you probably won't run into. And then the date and time, there's 3 primary ones: date, timestamp, and interval. And we are going to talk about those. For binary values or multimedia, we won't be using a lot of these. You know, JPEGs, WAV, these are sound files, and even there's video files now used in either the raw or the blob. But just know that these are some of the data types, the common data types, although I'm not going to ask you to use any of the expected large data types in our scenario. So basically to break down some of the data types and when they're used for character data types or strings, it's usually better to use varchar 2. Stick with varchar 2 for all of your strings, please. Clob and then char may save space, but let's just, for our purposes, stick with varchar 2. All right. And remember, when you're setting up your data type and giving it a size, make sure that you allocate enough size for whatever you're using, like address and or name or whatever. But it does speak to other string data types. I will say again, for our purposes, it's probably best to stick with varchar 2. Number values, they can be negative as well as positive. If you have an allocation like this, 6, 2, that means it's looking for six digits on the left side of the decimal, 2 on the right. And so in this case, you can store in the 6, 2 plus 9999. Remember, okay, I said that wrong. I apologize. 6 is your total number of digits. 2 is the number of digits on the right side of the number. So this 6, 2 can go from 9,999.99 to negative 9,999. All right, the date data type. Once again, it's what I would do if you're curious about that particular structure. I would just do a default sys date. It's a little bit different than what's illustrated here. It's a 2-digit year now. We're well past the whole concern about Y2K. So it is a number three letter month and then a 2-digit year. And we had looked at that before, so you can refer to that again. You can do a query on any of the tables that have date, and you can see the default or the normal system sys structure of your date. Or I do recommend that because that can be confusing, especially because of the fact that it's different than what's illustrated in the lessons now. And I do, I'm going to have to take the time to change that. Now timestamp is a little different. Basically, you can add your minutes and your seconds and your microseconds, and etc. If you need that, it will give you the exact time. And here's some examples of how the timestamp data type can be used. Is it necessary? Well, most systems will extract and extrapolate date, time information for you without you illustrating this particular data in your column. That's a date column. If you're working in a scientific environment and they need microseconds or nanoseconds, it is probably possible, or it is possible that you may have to illustrate it this way. But for our purposes, we're going to stick with just, hours, minutes, and regular seconds. All right, so this talks about time and time zone, which is pretty important. So when you think about time values like 1730, we know that that's 5:30 p.m. Of course, it means 5:30 in the afternoon. But in which time zone? So if it's in New York or Beijing, or Istanbul, in today's globalized organization, as I said before, you have to be very particular about understanding the time zone, since there's many of them, 24, to be specific. You can be that granular and talk about specific time zones. Most of the applications now that deal with email or cloud services, all you need to do now is just select your specific time zone. And if you are speaking to someone in the UK, which is essentially the foundation what time zones are based on, that's where the Greenwich Mean Time comes from. Well, anyway, generally it's not a big deal. You just need to either calculate in your head or use some of the application parameters where you're just selecting the specific time zone. But I do want to illustrate that the Greenwich Mean Time, or GMT, we're, what are we now, +7 hours behind. But we have our Eastern time zone, we have our Mountain time zone, and yes, we have our Arizona time zone because we don't follow the whole daylight saving time, so we have to be different in oddball life. As far as essentially creating your table with the time zone command, here's an example. This is giving you a time with offset. That's nothing, merely the column name, and timestamp with time zone. And when you use it with time zone, it'll take whatever the system time is and calculate based on whatever you enter. So here we're inserting a value of this particular time +2 because we're actually building in the offset. Generally, if you need to do something like this, and you will have plenty of chances to run this. Oops. Was there a question, comment? Someone unmuted. We have lots of echoes. I wonder why. Is that me or is that? Is anyone else hearing an echo? Okay, someone unmute and say something. No one wants to volunteer.
Hello.
Okay, that's,
I can hear you good.
thank you. Thank you, Whitfield. All right, so that was just an anomaly. Let's see. All right. Hopefully, it's just something that someone may have a couple of devices. But anyway, let's continue. And you can set your local time zone. As I said, it's not such a big deal now currently, because most applications will adjust. I can remember this was such a bother before, and you'd have to account for it within your database. But I can unequivocally tell you that generally, as long as you're setting or using the sys date, I mean, basically it looks at your system clock, and then you can even, well, as I said before, you can create your offset, but most operating systems, not necessarily Windows, will adjust based on your location, since that's all a part of how these operating systems work, which will be incorporated into your database. So that's, although I think Windows is attempting to do that now, Windows 11. But anyway, let's continue. Here's another time zone example. Basically, we're accounting for a particular user, internationally. We can create an offset so that we can see exactly the time. If you follow a particular offset that you've set, which you rarely will see, but you can, or you can transfer the data or transfer the idea that your particular time zone, if you're Arizona time or New York time, etc. All right. There's an interval data type. These actually store elapsed time or interval of time between two date time values. Excuse me. Interval year to month. So there's a period of time measured in years and months. Interval data second stores a period of time measured in days, hours, minutes, and seconds. And here's an example, or here's the syntax. Interval year precision to month. Year precision is the maximum number of digits in the year element. The default value is 2. Let's see if we have an example here. So this example shows the interval year to month and how it's used. Basically create a table, long duration 1, interval year 3 to month. Insert into this particular table long duration. So we're basically identifying long durations, whether it's 2 years or 3 years. And so year to month, 3, interval 120, month 3, interval 3 to 6, year to month. So basically, you can illustrate that in this particular scenario when you built this table. So assume today's date is July 17, 2015. Yes. If we select sys date plus long duration as 120 months from now, we can see that basically we're almost to the, which is 10 years from now, which is July 17, 2025. Okay, 3 years and 6 months from now. Yeah, so that you're just defining an interval for if that's needed. Is that needed? Well, you could think of a scenario. There's always a scenario for some of these particular data types. So interval data second is essentially the same idea. Basically, if you want to create an interval, let's see, the syntax is very similar to that year to month. Day precision is the maximum number of digits in the day element. The default value is 2. Oops. All right. So if we look at an example of this, if we create this particular table, day 3 to seconds, interval day to second, and look at the example, we want to look at something 25 days. And there's obviously different ways to do this, but this is a way that you can create these data in a table at the very beginning. If we want to look at these precise intervals, we're looking at 25 days or precise days and times from now, etc. All right, so data types was the topic of this particular section. We looked at some data types, clob and blob. I like those, but they're rarely used in this scenario. Timestamp with time zone, timestamp with local time zone, interval day to second, interval day to month, along with the regular data types, your varchar, your number, and your date. All right, those you'll be primarily using. When you get into the demo for 13, make sure you test some of the other data types. All right. Okay. On to modifying the table. Basically, our objectives: explain why it's important to be able to modify a table, explain and provide example for each of the DDL statements: alter, drop, rename, and truncate, and the effect each has on tables and columns. Construct a query, and execute the alter table command, add, modify, and drop. Explain and perform the flashback query on a table. The flashback query, I think it still works. Explain and perform flashback table operations, track the changes to data over a period of time. Explain the rationale for using truncate versus delete for a table. There is a rationale. Add a comment to a table using the comment on table command. Name the changes that can and cannot be made. Modify a column. Explain when and why the set unused statement is advantageous. A lot in this topic. Most of it is useful. So we will go through these objectives. So remember the statement: there's nothing permanent except change. Oh boy, that's cliche. Would it be nice if we never made mistakes or needed to change anything? It would be nice. As you know by now, databases are dynamic entities. Yes, they're always changing. They probably wouldn't be very useful if they couldn't be changed. So up to now, we've created tables, or we've talked about creating tables and made changes to the role data inside tables, but how do you make changes to the table itself? And that's the whole idea here. We're going to look at the DDL commands to change the table. Let's start with the alter table command. This is used to add a new column, modify an existing column, define a default value for a column, or drop a column. And this is alter table. You can add or modify a column in a table, but you cannot specify where the column appears. And usually in Oracle, the column will appear at the end, despite your best efforts. You'd have to rebuild the table exactly to signify where the column appears. So yes, I just said this: a newly added column is always at the end or at the last. It's the last column. Also, if a table already has rows of data and you add a new column in the table, the new column is initially null for all the pre-existing rows unless you have a default. So, all right, here is your syntax for alter table. This is adding a column. So alter table, your table name, add, the keyword add, your column name, your data type, and a default expression if you're using one, and so on. So here's a couple of examples. That's my CD connection, add release date. And then in our new my friends table, we're gonna add favorite game, and it's a varchar. Pretty straightforward. Alter table. All right, that's to add a column, right? Now we can use alter table also to modify an existing column. Modified column can include changes to a column's data type, size, or default value. And there are some rules and restrictions when you're modifying a column. There are a couple that are pretty important. So you can increase the width For precision of a numeric column, you can increase the width of a character column, the varchar 20 or whatever. You can decrease the width of the number column if the column contains only null values. Remember that. Or if the table has no rows. For varchar types, you can decrease the width down to the largest value contained in the column. And that just means if you have like a large name, you're changing the last name column, and someone has a 20 character name, you can't decrease it below 20. You'll get an error. Okay, you can change the data type only if the column contains null values. That should be common sense. If there are values in that column, you can't just arbitrarily change the data type. You can convert a char column to a varchar, or convert a varchar column to a char column only if the column contains null values. So usually you're converting a char to a varchar because the char is fixed, varchar is variable. A change to the default value of a column affects only the later insertion to the table. So let's say you wanted to add a default. It's not going to change the existing data. Remember that. It'll just change any additional values added to, or records added to that data, to that table, excuse me. So here's some examples. So we created this table initially with last name and salary, right? So which of these modifications would be allowed and which would not? So if we think 1, 2, 3, 4, if this is our table, which one of these alter table commands or queries would be allowed? I should play my Jeopardy music. Anyone going to answer this? Your mom says 1 and 4, 1 and 4. Because we're increasing the size, so yes, that's not going to be a problem. And then, well, we're decreasing the size, but we need to know, the data that's in that. Or wait, why would 2 not be allowed if we're creating this table? Although we're just creating a mod temp table with last name, we're assuming that there's no data in that table. So anyone else agree for line only 1 and 4 will be allowed? No one else wants to speak. All right, so this one will be permitted only if columns were empty or the largest name was 10 or less. So basically, all 4 will be permitted. It's really based on the data that's in that table, if there's any. All right. So all would be permitted. All right, dropping a column. When dropping a column, the following rules should apply. A column containing data may be dropped. A column containing data may be dropped. Only one column can be dropped at a time. You can't drop all the columns in the table. At least one column must remain. Okay. Once a column is dropped, the data values in it cannot be recovered. So you can drop a column, and this does occur periodically if there's data in it. Just remember that. Be very careful with dropping columns. All right, and here's the syntax. It's basically alter table, drop column, column name. And here's our examples. Alter table, drop column. Set unused columns. This is another DDL command. Dropping a column from a large table can take a long time. A quicker alternative is to mark the column as unusable. The column values remain in the database but cannot be accessed in any way. So the effect is, so basically, if that table is being used for some reason, you can set the column as unusable. So basically, you can block it from usage and then just drop it.
And the syntax is alter table, table name, set unused, and then your column name. I've never used that, so even in my big data days. So here's an example. And so alter table, set unused, and then drop unused columns will remove columns currently marked unused. So then you can drop all the columns that's marked as unused. It's a quicker way than dropping one column at a time, etc. So that's the set unused. So here's the alter table summarized. Add a column, modify a column, drop a column, set unused, and drop unused. So be very careful when you're dropping columns, because you can drop a column that has data in it, and then you end up having to do something else, which is what we're going to talk about. All right, you can drop a table. When you drop a table, it removes the definition in Oracle. The database loses all the data in the table and all the indexes associated with it. When a drop statement is issued, all data is deleted. The table's description is removed. The Oracle server will not question your decision. You don't get a second chance. It will drop the table immediately. That's the power of a drop table command. It gets rid of the table. There is a way to drop, well, basically you do have drop any table privileges. So you can, the syntax is just drop table name, and there's an example. So once again, be very careful using that particular command. However, you're thinking if you drop a table by mistake, you may be able to bring that table and its data back. It really depends. In our instance, I wouldn't by using the flashback table. So each database user has its own recycle bin. You know, you have your own recycle bin on Windows, and you can actually go there and recover items. The flashback table command can usually recover your table. There's a specific thing that you have to do. So this protection here, this syntax here, flashback table, your table name to before drop. So it's basically a return, an attempt to return your table to active status. It says may because sometimes, depending upon your database and your constraints, etc., you may lose the table forever. So for example, if you drop the employees table in error, you can restore it. And here's our restoration process. I think you can do that on the instance here. What I would do to practice with that is to create a copy. You know how to create a copy of a table, and then run the flashback table command. Yes, Oracle does have what's known as a recycle bin. You can actually check that in the data dictionary, and it'll actually have the status of the table as dropped. So if it's flagged as dropped, then yes, your recovery will be successful. So that would be the way that you could check the whole drop scenario. Well, once a table has been restored by the flashback command, is no longer visible in that recycle bin. So it goes back to active status. So you can rename a title of a table. Yes. So the syntax is rename old name to new name. Yes, you can run that as well. Okay, truncate. Truncate a table removes all rows from a table and releases the storage space used by the table. Basically, it clears all the records. When using the truncate table statement, you cannot roll back row removal, so you can't recover the data. You must be the owner, and you are the owner, to run the drop any table. So the difference, well, let's go through this. The syntax is truncate table and then your table name. The delete statement also removes rows from the table, but it does not release the storage space. So the big thing here is that it releases storage space. It removes all the data, and it's very fast, but it does not generate a rollback information. Okay, that's truncate. And the difference between truncate and drop, truncate does not remove the table structure. It just removes all the data. Just remember that. All right, you can actually create a comment for your table. You can add a comment up to 2,000 characters about a column or view by using the comment statement. And the syntax is comment on table, table name, column, table, dot column, is, and then place your comment there, and then it will show up on the table in a described table. So here, comment on table employees is Western region only. So it's basically something that you could add to provide clarification for your table. To view the table comments in the data dictionary, you just go to user table comments or user tab comments. It'll give you the comments and the table that it's commented on. And if you want to drop the comments previously made on a table or a column, use the empty string comment on table employee is, and just an empty string, and it's basically, it will replace whatever the comment was with empty text. All right. Flashback query. You may discover that data in a table has somehow been inappropriately changed. Happens all the time. Luckily, Oracle has a facility that allows you to view row data at a specific point in time, so you can compare. Yeah, it's a pain when you have to run this, but it is useful. Or if there's a question about the validity of data, you can actually do a timeline on the data. You can use the flashback query facility to examine what the rows looked like before they were changed. So basically, it keeps a running tab. Think of it that way. These old copies are held in a special place, and it's called the undo table space. You can access the special area using the flashback query, and I'll show you that in a second. You can look at older versions of data by using the versions clause and the select statement. So take a look at this example. Select employee ID, first name, last name. You can concatenate there as name, version operation as operation, version start time as start date, versions end time as end date, salary from employees, version between min value and max value. The SEN number referred to means the system change number, and so it'll give you a precise identification of the time that the data was changed, and it'll give you a sequential number. So once again, it's very useful to run a query like this because you can track if for some reason the data was changed, how and when it was changed. So in this case, this is our example. Let's see, the best way to demonstrate it, yeah. The contents are as follows for employee ID 1 in the employees table. So since we're running this based on employee ID 1, this is no data found. But if we add that particular employee, remember we're inserting this into our employees table, this particular employee is employee 1, and we run this version, then you will receive something like this. Basically, employee 1, the date and time, it would be today's date, whatever value we would write into that. Is that useful? Yes, if you have a lot of data points on a particular record and you're not sure, what has happened because the data is incorrect, you can run this flashback query scenario and make the appropriate corrections with another, update for your record. And that's what it's illustrating here. We're running an update, so then it just tracks, and you'll see when you run these type of queries, you can see it basically creates a log of how the data has changed, which can be useful. and so on. See all the mini changes. So it even tracks when you delete the row, delete, update, insert. That's the DUI there, not driving under the influence. So essentially, the flashback query, once again, it just creates a way that you can log, and you have to use this particular syntax to build that. Okay, so this has been the alter table scenario, or modifying your table. We can add, modify, and drop columns, drop the table, rename, and truncate. All useful. And then comment on the table, flashback query, and set unused for that column so that you can easily drop it. All right. Okay, so let's continue to buzz through section 13. And then we'll take like a 2-minute break, and we'll go on to 14. Trying to keep you too late. All right, our videos in 13 are very useful. Create table, alter, drop, etc., truncate. Please view those. And then, as I said in the demo, there's tons of queries that you can try on our schema. It's always useful to go through these, at least a few of these, to make sure you can see how they operate or function in the SQL developer. All right. We're not going to do importing and exporting data, so I'm not going to go through that. You can read through that for information yourself. It's something that we don't really need to learn SQL at this juncture. And then you have the 3 levels of practice on the 3 topics, and your solutions. And then for section 13, you just have the assignment. Nice little 1-pager. Basically, you're running a couple queries, and then you're running a couple through the data dictionary, user table, user objects, etc. All right. All right. So what I'd like to do now is just take a 3-minute break. Let's restart at 7:15, and we'll go on to section 14. All right, 7:15. Stand up and stretch, and we will be back at it in, well, somewhere around 7:15. So I will be right back. Don't go anywhere. No one will have to make sure everyone's in. All my attendees. All right, so no one goes anywhere. We'll start up in a couple minutes. Finish my attendance. Thank you all for showing up. I was a little concerned. Everyone's here. All right. All right.
Okay, I'm back. Let's get back into it. So that was, we just buzzed through section 13. Now we're going to hit section 14. Okay. Yeah, it's a good time to grab some water, stand up and stretch, go outside and get cold and run back in, whatever. All right. So here we go. Where am I? There. Okay, on to section 14, constraints. There, we're going to talk about an intro to constraints, not null and unique constraints, define term constraint as it relates to data integrity, state when it's possible to define a constraint at a column level, when it's possible at a table level, state why it's important to give meaningful names to constraints, as with anything else, state why which data integrity rules are enforced by not null and unique constraints, write a create table statement which includes not null and unique constraints at the table and column levels, explain how constraints are created at the time of table creation, excuse me. All right. So here we go. Constraints are pretty important to understand because it does provide a way for you to understand the restrictions around certain things within your database. So if you think about it, how would society function without rules? Yeah. It is a rule to stop at a traffic light, red traffic light. Would it be safe to drive without this rule? Yes. No. For databases, it is a rule that a foreign key value cannot be entered without first entering a primary key value. I mean, just that relationship between foreign key and primary key. What do you think would happen if a database, if this, yeah, a lot of these things are pretty much common sense. Constraints basically are the way to prevent invalid data entry. Basically, it creates a way to validate the data and make sure the validity is always there. And so on. There's a lot of examples, but just think of constraints as rules that should be abided by within your database. And you can also learn how to manage them and view constraint definitions in the data dictionary. And I'm reading Lam's comment. It also prevents some columns from being deleted. Yes, there are constraints on things like deletion and drops, and there's inherent constraints in there that helps you from not doing something that you shouldn't. Although as a DBA, you can bypass a lot of the constraints. So, all right. So what exactly is a constraint? Think of constraints as a database rule. We just said that. All constraint definitions are stored in the data dictionary, and constraints prevent the deletions of tables if there are dependencies from other tables. So all this is not magic in the back end. This is all controlled by constraints, and that's what it is. It's just rules that are defined initially and redefined within your data, within your database, excuse me. Constraints are important, and naming them is also important. Although you can name a constraint 1 or constraint 2, it's soon be difficult to distinguish. Basically, you want to name them appropriately for what they're restricting or the rules that they're signifying. So recall the SQL syntax for creating a table, create table statement shown on the next slide, etc. Use the create table statement to establish constraints for each column in the table. There are two different places in the create table statement that you specify constraints. That's at the column level and the table level. So you see here, we have constraints, create table clients, client number 1, first name, varchar 14, last name. Note that the column level simply refers to the area in the create table statement where the columns are defined. That's where you would define constraints, right where the columns. The table level refers to the last line
in the statement below the list of individual columns. So before the semicolon, you would have, table level constraints in it. I will show you that. So here is a column level constraint. This refers to a single column. And to establish a column level constraint, you would do this client number. Now, number 4 constraint is this particular, basically we're defining this particular column as our primary key client. And this is our constraint, client number PK primary key. So that's all associated with client number. Okay. Hopefully that does make sense to y'all. So the name of the constraint is client num PK, and it forces the business rule that client number is the primary key. Every constraint database should have and has a name. And when a constraint is created, it can be given a name such as this here, or given no name, in which the system gives the constraint a name such as CIS, something that looks like this. That's why you want to use a naming convention so anyone can go back into the description of your table and see where there's constraints. If the reserved word constraint is used in a create table definition, you must give the constraint a name. Constraint names are limited to 30 characters. And some of them, I know this one is pretty, client num PK. I mean, but there's a reason why that particular constraint had that name. So it's best to name constraints yourself because the system generated ones are, not easy to recognize. So look at this table definition. Why? According to our naming convention, a primary key constraint on client number would be named clients. So that's table, a column, and what we're going to do with it. That's why you have all that. The not null constraint on last name would be name, client's last name. Yeah, not null, NN, that's what that is. Unique constraint or email address would be named client's email UK unique constraint. And there's essentially, this is just going over the naming convention so that you get an idea and an intuition of how they should be named. So this example shows both a username constraint and a system name constraint. So username constraint, client number, and then simply not null, that is a constraint. That means that this column cannot be, last name cannot be null, right? All right, so the two that are created is that clients, the primary key, and then a system constraint basically is saying that the last name cannot be null. So yeah, with this type of constraint, yes, simply indicating not null is creating that constraint for that column. All right, you can create table level constraints. It simply needs to be the last line after the last column listed, within the parentheses and before the semicolon. Essentially, you have to, you label a constraint, you give this constraint a name, a type, and then the columns that it's associated with, email and phone. So this is going to be associated with, basically says the email and phone has to be unique. But that's a table level constraint. All right. You can do either a column level or a table level. So constraints that refer to more than one column, they're called composite key, and they must be defined at the table level. The not null constraint can be specified either at the column or the table, or excuse me, the not null has to be specified at the column, not the table level, because you don't want the whole table to be not null. Unique primary key, foreign key, check constraint can be defined at either the column or the table level. If the word constraint is used in the create table, you must give, yeah, we said this already. So in this example, we're using both column level and table level constraints. And see, it's not really column level here. Now this is hard to read, but the constraint here on, let's see, what is this constraint? Oh, that's a mess. I'll have to clean that up. But composite unit key restriction, define the table level. These are all table level constraints. So there's a lot of errors. Yeah, if you use the keyword constraint, you have to have a name. You can't really differentiate between, oh, that's really kind of bad. Anyway, I will, if you need an example, I can clean that up. Anyway, there's 5 types of constraints that exist in the Oracle database. Each type enforces a different rule. Not null. These are the ones that exist. Not null, unique, primary key, foreign key, and check constraints. So in the remainder, you'll learn about the not null and the unique constraints. The next lesson, I'll teach you about other 3 types. The column defined with not null constraint, just essentially, all this is summing up to say that you can define a column level constraint where that column cannot be null. That's a constraint. A unique constraint requires that every value in the column or set of columns, which if it's a composite, be unique. That means no 2 can be the same. And generally, you'll see this on email addresses. And there's a reason for that. And it's usually a composite, last name and email. Because sometimes, well, if someone has the same first initial, whatever the email construction is, but the unique key constraint is very important when it comes to, and generally you will create a table level constraint where it's several values. First name, last name, phone, and email will be unique. And that's what I'm illustrating here. And this is a unique constraint example. And when you create these constraints, basically you prevent yourself from making mistakes like with this email address. You know, you're trying to insert a value that already has an email address, even though we have Lauren Vigil and Lonnie Vigil, but you would have to create some type of constraint or modify the constraint so that it'll allow us to enter in, maybe it's brother and sister or husband and wife or whatever. So you would probably use the phone and the email as a composite constraint, but. So basically in naming, you want to use the suffix UK, which means unique constraint. That's why you see that. And usually you will see the keyword, if it's table level, unique, and then the columns. So we modified that constraint and we created a composite constraint, email and phone, which is what I said before. So now we can enter in Lonnie Vigil along with Lauren Vigil. We're not restricted, and they can have the same email address. All right. You can create constraints, and usually it's the case when the table is created. That's probably, especially the sys constraint, not null. But as you know, you can modify your table using the alter command and create constraints there too. But that table creation is usually the most effective or best time to create or to add your constraints, excuse me. All right, our key terms for this topic: check constraint, constraint, column level, foreign key, not null constraints, primary key. Right. Table level constraints, unique key, we had composite in there. Well, unique composite constraints, which you generally need when you're combining two or more columns. All right. Okay, moving right along. Let's take a look at primary key, foreign key, and check constraints, which we mentioned those in the last section. We're going to illustrate exactly what those are by define and give an example of these constraints, explain the purpose of defining, demonstrate the creation of constraints at the column level and table level. And y'all know that basically the reason why you have primary key, foreign key constraints, that enhances that relationship scenario within your relational database. Allows you to do things like join or implicit, explicit, etc. So we know that constraints are used to define these specific rules. What would happen if surreptitiously, that word, or just through your careless mistake, your personal unique identification was given to another person? Well, ensuring data integrity is truly the whole reason why you're using data, constraints for your database. All right, primary key, this one is pretty important. The primary key constraint is a rule that the values in one column or a combination of columns must be unique to one specific role or record. All the tables in a relational database scenario will have an index or a signifier of that record. That's your primary key. So your primary key has to be a unique value. Usually it's an auto-generated, auto-incremented, or some type of ID that will be associated with one record. So the primary key, no column that is part of the primary key can contain a null. The table can have only one primary key. And remember, primary key is a full column. The primary key is usually defined, it can be defined at the column or table level. It's usually defined at the column level. However, if it's a composite key, then it has to be the table level. And the many newer databases are using a composite key for your primary key because of the sophistication of the data of the table. So when naming a primary key, the suffix should be _pk for primary key, the one that we saw before. Yeah, this clients. So that's just signifying primary key, and you do in that with the keyword primary key when you're creating your table. And this is usually where you want to define your primary key. All right. You can define it at the table level. It's pretty much the same syntax. If it's a composite, you want to define it there, but this particular query is the same as this. You're just defining it at the table level. Same structure, constraint, name, primary key, and then your column. And this is the way you would define a composite primary key, two or more columns. All right. There could be a reason for that, but I would say generally you want your primary key to be as simple as possible because that's your identifier for your record. Foreign keys are truly dependent on the primary key, and it's illustrated in a way that we call referential integrity, and that constraint is defined that way. They're defined that way because it's dependent. Remember that foreign key always links back to a primary key. That's a referential integrity. There's a very distinct reason for that. You only create a foreign key because you need to have that connection and that relationship to whatever the primary key is. So the table containing the foreign key is called a child. The table with the primary key is the parent. So in ours, we have the employee and department tables. They both have a column department ID, or yes. And in our department table, which is our parent table, the department ID identifies the department. In our employees table, which is the child, the department ID is how we're using referential integrity, basically to signify what department the employee is in. So, and you can see that relationship. And usually, if you understand that cardinality or how that creates a relationship, you can really kind of comprehend the whole idea of a relational model as far as databases, right? And that's what I just. So when you're defining the foreign key in the employees table, then if you're altering it or whatever, then you would use this particular naming convention you see here, IMP's department ID foreign key. So that's creating that constraint or referential integrity for within your employees back to your departments table. And here we have our column. Remember, this is a column specification. Okay. And there's a couple things that you have to include. Your column, and it's a number, data type, your constraint, that's a name, and you have to reference. If it's a foreign key, if it has a foreign key, you have to create that referential integrity. You're referencing it to the departments table and the column in that table. Remember, you must have that if it's going to be a foreign key. Now you see here, there's not a foreign key keyword. You just use the word references. That is saying that you're creating that referential integrity, right? And you can create it at the table level as well. It's the same syntax. You just have to identify the foreign key. See the difference here? If it's at the table level, then you can use the keyword foreign key of that column in that table, and then it's referencing the department, referencing the departments table and that column in the departments table. So make sure you signify whichever level by that particular syntax. All right. All right, on delete cascade, maintaining referential integrity. And this is the one thing that you must do if you want to modify or change or drop tables that have a foreign key primary key relationship. Use the on delete cascade option. And basically, this will define any child-parent relationship. If it does not have that option, you can't delete the table. In other words, a child table constraint includes the on delete cascade permission, allowing its parent to delete the rows that refer to it. So that's what, if you read that on delete cascade, it's basically cascading the relationship. And here's our referential relationship between the departments and the employee. And if the department ID column in employees was created with the on-delete cascade option specified, the delete statement issued on the departments table will actually execute. If it's not specified, then yes, it will fail. You will get an error. So this is what will happen right now if you try to delete that column. And that's if the on-delete cascade was not specified for that column. And the specification is simply this. Once you define the constraint, you add the keywords on delete cascade. Right? And that means, this is important because let's say you want to delete a record in one of the tables. If you don't have on delete cascade, you won't be able to, because there's a referential integrity and all that. And then there's on delete set null. Rather than having the rows in the child table deleted, when using an on delete cascade, the tables can be filled with null values. So, and here, if we wanted to delete an employee, basically, well, either way, employees as a foreign key, it'll just set that record in that particular table to null values. So you don't actually delete it. Maybe you want to fill it with different values. So both of those are useful depending upon the scenario. All right, check constraints explicitly defines a condition that must be met. To specify the constraint, each row in the table must make the condition either true or unknown due to a null. So the condition of a check constraint can refer to any column in a specified table, but not to columns of other tables, just in a specified table. So it's basically a way to check your constraint. So this check constraint ensures that a value entered for an end date is later than the start date. So we're just making sure using this constraint that you're actually having the time association correct. So you use the keyword check, and then the condition end date has to be greater than start date. It's just creating another rule. That's all it does. Always very useful. All right. The check constraint must only be on the row where the constraint is defined. The check constraint cannot be used in queries that refer to values in other rows, just on the row you're defining. The check constraint cannot contain calls to functions like sysdate, UID user, or user env. The statement check sysdate is not allowed. So you can't do something like this. It has to be check and then whatever your actual dates are. So you can't use sysdate in your check constraint scenario. The check constraint cannot use pseudo columns, so columns that are defined like curve value, mixed value level. These are pseudo columns in the system. The statement check mixed value greater than 0 is not allowed because that's a pseudo column. A single column can have multiple check constraints. There's no limit to the number, so you can have all kinds of check constraints on a single column. And check constraints can be defined at the column level or the table level. Remember, when you define at the table level, you have to identify the column. So here's a column level. Here's a table level. Salary greater than 0. Okay. All right. So for this topic, check constraints, foreign key constraints, referential integrity, not null, on delete cascade, on delete null, primary key constraints. All useful material. All right. One more, managing constraints. So list 4 different functions that the alter statement can perform on constraints. Write alter statements to add, drop, disable, and enable constraints. Name a business function that would require a DBA to drop, enable, or disable a constraint, or use the cascade syntax. And then query the data dictionary for user constraints and interpret the information returned. All right. All right, we're almost there. Okay, would it make any difference if a new student ID was entered into the school's database when no actual student enrolled? It is likely that a credit card company would issue the same credit card number. Yeah. What do you predict would happen if a business could not trust the reliability of the information in this database? That's a good question. A database system needs to enforce business rules and at the same time prevent adding, modifying, or deleting data that might result in a violation of the referential integrity of the database. that particular standard has been around for a long time. So we're going to learn about, making changes to table constraints so that the referential integrity and in turn database reliability are maintained. All right. The alter table statement is used to make changes to constraints. So remember that. On existing tables, these changes can include adding or dropping constraints, enabling or disabling constraints, and adding a not null constraint to a column. Okay, there are guidelines. You can add, drop, enable, or disable a constraint, but you cannot modify its structure. So remember, add, drop, enable, or disable, but you can't modify it. Basically, you would have to drop it and redo it. You can add a not null constraint to an existing column by using the modify clause of the alter table statement. Modify is used because not null is a column level change. And you can define a not null constraint only if the table is empty or if the column contains a value for every row. Remember that, only if the table is empty or if the column contains a value for every row. All right, the alter statement requires the name of the table, the name of the constraint, the type of the constraint, the name of the column affected by the constraint. So if you take a look at this code, this example, alter table employees, add constraint, imp ID, primary key, employee ID. So using this example, we can actually add the primary key if it was not on there before. Remember, you can only have one primary key after the table is created. All right. To add a constraint to an existing table, use the following: alter table, table name, add, constraint, constraint name, type of constraint, column name. All right. If the constraint is a foreign key constraint, the references keyword must be included. Yeah. Foreign key, remember foreign key references. All right. And basically it references a parent table. So let's consider the employees database. The primary key for the department's table is entered. We went through this. That's our primary key. That's our foreign key. Right. The following example demonstrates the syntax to add this foreign key to, if it was not added, we can add it this way. Alter table, add constraint, foreign key, employee department foreign key, references, department ID, on delete cascade, which means we can delete a record if necessary without any issue. That's only if the foreign key was not there. Adding constraints. Conditions, if the constraint is a not null constraint, the alter table statement uses modify in place of add. So you just want to add the not null, alter table, table name, modify, column name, constraint, etc. And here's our example: email constraint, if email not null. We're just saying that we want to add that not null constraint to our email column in our employee statement. So why enable and disable constraints? Well, to enforce rules defined by integrity constraints, the constraints should always be enabled. In certain situations, however, it is desirable to temporarily disable the integrity constraint. I've done this many times because of some particular issue. Loading a large amount of data is probably the biggest one, because if you don't disable a constraint, you could be adding one record at a time, which is kind of a nightmare. And it's usually some type of batch operation where, it's a large amount of data that's being added to a table. And if you could disable all the constraints, it'll make it a lot easier. Of course, you have to be very careful with the data. And I thought we had an example of, well, we will come to that. To drop a constraint, you need to know the name of the constraint, and if you do not know it, you can find it in the data dictionary. The cascade option of the drop clause causes any dependent constraints also to be dropped. So if there's dependent constraints, yeah, be very careful of. You always have to be very careful of dropping. I would always check what the constraints and the relationships are or cascading. No rows or any data in any of the affected tables are deleted when you drop a constraint. Remember that. It doesn't affect the data in the tables. So here's the syntax alter table, table name, drop constraint, the name, and then cascade or not. Generally, cascade, you want to use that to drop any of the relational constraints. And there may be a lot, so you have to be very careful with that. All right, so we talked about enabling and disabling constraints. So by default, whenever an integrity constraint is defined, the constraint is automatically enabled unless you find a reason to disable it. You can disable the constraint without dropping it or recreating it by using the alter table option, disable. Disable allows incoming data whether or not it conforms to the constraint. And that's the whole idea. Be very careful with that. And it's simply alter table and the keyword disable constraint. And you disable that constraint temporarily because hopefully you're going to go back and enable the constraint, which is the other side of that particular. And if you disable the constraint and use the cascade, then you're disabling all of the constraints that are associated with that. We're going to call it the primary constraint, and that's very dangerous. So as I said, and as it was illustrated before, usually in this case, you have some particular reason, probably a batch or something high level that needs to be done. So if you're going to disable it, make sure you go back and alter your table and enable that constraint right after you're done with your job. And as the keyword enable is used there. So that's very important. Your constraints were built for a specific reason. If you're disabling it for a purpose, you really should go back and enable it right away. And that's what it's talking about here. A lot of these constraints are there for a specific reason. So especially if it's a cascading amount of constraints, you have multi-columns, you have multiple tables, that can be a disaster. So as far as cascading constraints, generally, once again, be very cognizant of how your constraints are associated with each other. When a cascade is not required, basically, if there's no referential integrity or anything like that, that's considered. You can alleviate the cascade, but generally, depending upon, remember these databases are so connected that you can impact it in many, many ways. So be very careful in changing or modifying constraints. Let's see what else. So to view your constraints, there is a user constraints table in the data dictionary, so you can simply query that. And you can do a star, look at the column names with the constraint name, table name, etc. And even if it's enabled or disabled, that's one of the things that you should always check periodically. All right, and constraint type, primary, foreign, and reference. So, or check constraint or unique, they're all in there. All right, so our terminology, managing constraints, basically with your alter table command, cascade and a cascade clause, make sure you understand which constraints are cascaded. There's a way to disable and enable constraints, drop column and drop constraints. Once again, be very careful when you're dropping or deleting anything as far as your data. All right, I know that's a lot, but constraints are pretty straightforward. I do have a constraints syntax document. Please review this because it will basically re-illustrate the column level and table level constraint construction, adding not null and excuse me, typically altering your constraints. Another very useful document. And then we have our demo with all of our introduction, modifying, and managing constraints. Go through that, please. That will definitely help. And then our practice, three topics to practice on. All right. And the solutions. Yes, and there were no videos, just to document constraints. And pretty straightforward. And then we have the assignment, the specific constraint assignment. Basically follow the instructions. And they're pretty, as I said, these assignments are pretty short, so this shouldn't take you too long. And then for the last thing for this week is the section 1314 quiz. And it's 20 questions. Yes, and it's not too bad. You write one big query. Actually, there's not 20 questions. You have one last query that has several parts. It's 10 points at the end of that. So, all right, there you go. I know you're all exhausted. Any questions or comments about this week? It seems like a lot, but it's not a lot of work. And some of you, the overachievers, have gotten some of it done already. And I'm pretty sure they didn't spend that much time with it. So 13 was DDL and 14 is constraints. Creating tables, using data types, modifying tables, and constraints and all of their iterations. Okay. Any questions? I know it's been a longer night, but we got everything done. I appreciate you all hanging in there. Remember, the assignments are due this week, Sunday, midnight. So, all right, any comments, any questions? Yes, that's a good catch there, Adam. Yeah, you actually get two attempts at the quiz this week. That's different than, so if you feel like yeah, you need a second chance at it, yes, you can go at it again and it will record your highest score. Yeah, it's kind of stacked, but it's not. Yeah, it seems like more workload, but it's not that bad. I know, combining the two sections, but I did that because it's not too bad as far as the amount of work. But thanks for pointing that out, Adam. Yep, that's true. 2 attempts should be enough to help, right? The final project. I will begin that conversation next week more. I will detail that. There's a lot to that. You will have quite a bit of time to complete that. So, but I will start that conversation next week. Or actually, yes, next week. And then next week is Thanksgiving, so I'll try to make it much lighter so you all can enjoy your meals. But yes, we'll start the conversation on the final project and a little bit on the final exam too. So, all right. Okay. That's all that we have for this evening. Yep. There's a little bit more work, but it's not too bad. You all will be okay. All right. And just a quick summary, just DDL creating tables and then constraints and you'll all be good to go. All right, take care, everyone. I will see you all next week.
Thanks. See you next Monday.